Good morning. This is Mr. McMurray, and we're back at pulleys. All right. We have here a single fixed pulley at the top and a single movable pulley down here, which is the third one on our list, and that's what we're going to do next. Just a little quick refresher to remind us how we're doing things. We're going to be on this one, single fixed, single movable, and the resistance force is still going to be 2.0 newtons because we're using the same size weight that we did in the past. The effort force is going to be when we pull on the spring scale to see how much effort it takes to lift this particular weight. Okay, and for the two distances, we're going to use the sheet up here. I'm going to measure where and call out to you where the weight begins and where the scale begins. Then I'm going to move it a certain distance. And then we're going to put where did the weight end up and where did the scale end up. Then you'll subtract those two numbers. This will give you the resistance distance, or DR, which goes there. And subtracting these two will give you the effort distance, or DE, which will go here. Now, if you get a negative number, don't worry about it. Just change it to positive. We're just worried about the distance. We're not worried about whether it went up or down or whatever like that. All right. And then the rest of these have a formula for them. All right, don't forget efficiency. You take this divided by this and then times 100. But I just didn't have time or room to squeeze that in there, so I did not. But let me go ahead and put that because it is a percentage. So that should be times 100. Okay, just put it there. So now it's there. Okay, without excuse. All right, so let's get on with it. And let me get closer here, and I will call out the numbers and let you write those down. All right, so we know the resistance force is 2 newtons because this is a 200-gram weight. Okay, now if I pull this down, the effort force is all right, 1.0 newtons. Okay, so 1.0 newtons. Okay, and that is the effort force that it takes to lift this weight. All right, so you put that down under FE. All right, now we're going to do our distances. All right, so get your little half sheet ready. All right, we're going to start at 0.20 for the starting point for the scale, so 0.20 meters. And we're going to start at 0.330 meters for the weight. All right. Now I'm going to move this one 10 centimeters, so it's going to be 0.30 meters and 28.3, so 0.283 meters for the final on the weight. So 0.300 meters for the scale and 0.283 meters for the weight, I believe is what I said. All right. Okay. And that will be that. If you'll subtract the two distances and then subtract the, if you subtract the two distances, get no old hair, can't squat down like this very long. Subtract two distances to get your resistance distance, that go for DR at the bottom, and subtract your two distances for the scale to get your DE that goes down on the bottom, and then you can calculate the rest of them off to the side. All right, let me go to our next one, and then we will be ready to go. All right. Here we are on our next one. I don't know how well you can see this, but there are double pulley up here. So we have a fixed double pulley, and we have a movable single pulley down here. All right, and so when we pull on this one, all right, the top one stays there, but the little one goes up and down. All right, so let's take some measurements here. All right, so first of all, while we're moving this, it's going to be about 0.75 newtons, okay? 0.75 newtons, all right? And that's going to be your effort force, okay? Once again, we still have a 200 gram weight, so it's still going to be 2.0 newtons for your resistance force. All right. Now, if we're going to do our distances, let's get ready for that. All right. I am going to start at 0.200 meters for the scale, beginning distance for the scale, which means the beginning distance for the weight is about 55.2, so we're going to say 0.552 meters, okay, for it. Now we're going to move this one down to 30, so that makes it 0.300 meters for the thing, and that brings us to 51.8. Right? So 51.8 or 0.518 for the distance that it went. I forgot something. Okay. Now, that would give you your final distances for that. Okay. You can calculate the rest. Now, don't forget question number 2. It asks you how many string segments are there. Okay. Well, if we look at this, there's one here, one here, one here, and one here. So that's a total of 4, but this spring one is, the scale is pulling down. We said it only counts if it pulls up. So on question number 2 for figure 4, you would say there are 1, 2, 3, and we would expect it to have a mechanical advantage of somewhere around 3. Okay? All right. Now, if I let that go back up, let's go back to figure 3, the one we just did a second ago. We're going to have to hurry back here. All right. And if we look at this one, we want to know how many line segments or string segments are there. There is 1, 2, 3. But once again, this one's pulling down, so it does not count. So the scale one does not count, so just 1, 2. Okay? So you would put, for figure 3, you would put that there are 2 string segments. All right? And one more pause, and then we'll get to the final pulley arrangement. All right, now it's amazing how quickly this goes when you already have them all set up. Setting it up is the tough part, and the good news is you're not having to do that. All right, so, oops, forgot my meter stick. Hang on, I'll be right back. All right, so here we go. Now, we are ready once again. We're going to measure. This time we have a single double pulley up here. It's fixed, and I mean a single double pulley. We have a fixed double pulley up here, and we have a movable double pulley back here. So now we've got a total of 4 pulleys being involved. All right. While we're thinking about the strings, let's just talk about that real quick. Okay. We have 1, 2, 3, 4, and we have 1 over here. So we have 5, but this one's going down again, and so it does not count. So most of the time, guess what? It doesn't count. There's very few times that it does. Just the one on figure 2, I think. And so basically, it would be 4. We would expect it to be mechanical advantage of 4. So on question number 2, down below the chart, the second chart, just put for figure 5, we would have 4 strings. Okay, segments, 4 string segments. Now, let's do the force first. We'll see how much force it takes to keep this going. All right, looks like about 0.5 newtons. Okay, so 0.5 newtons. All right. You'll write that one down. All right, then we are going to do the distances. It takes a lot of rope to make this pulley. I shouldn't point out the last 2 pulleys. You've seen white strings. That's because we need a special longer string, because the more pulleys you have, it takes a lot more string to set them up. And as you may have noticed, they don't move as far. All right, so here we go. We're going to set this one at 0.20 meters. So the starting distance for the scale is 0.200 meters. All right, and for the weight is going to be 22, so 0.220 meters, okay? 0.220 meters. Now, if I move this down to 30, okay, so it's 0.300 meters, okay? So basically move 10 centimeters, all right? Then we're going to take this one, and this time it's going to be 19.8. So we're going to say 0.198 meters. All right? And so, yeah, that is going to be our two measurements. And for the weight, that's the final one for the weight. And so if you write those down and do your calculations, and then if you'll try to answer the questions that follow that. Okay? Once again, as always, if you have questions, feel free to email me, and I will eventually get back to you. I can't guarantee it'll be just lickety split because I got to have a day job. But I will get back as soon as I can to you. All right? Have a great day.